Okay, ready, Eddie? Good to go.
Thank you.
Okay, hello everybody. Up next we've got Katharine Jarmul, who's going to give us a performance and accuracy review of the top Python scraping library. So please welcome her.
Hello. Hi, everybody. I'm here for Python Scraping Showdown. Hopefully you are too. If not, please see the directory in the hallway. My name is Katharine Jarmul, also known fondly as KJam. A little bit about me. I've been using scrapers since 2010 after Ashish inspired me. I went to his scraping tutorial. If you get bored of this talk, he's giving a rather fun talk with Karen over a couple rooms down. Evidently, my Google delay is a little delayed. A little bit more about me is I am the PyLadies co-founder, or one of the PyLadies co-founders. I'm happy to see a lot of PyLadies here with me today. Let me try to move us along. Apologies. Evidently, everybody is on the same network. Imagine that. Let me see if I can. So maybe, apologies again. Well, Mac, you have failed me. Not sure if there's a better way to go about this. Yeah, sure. Sorry, everyone. Thanks. Okay. All right. Let us see if I have better luck here. Apologies again. Okay, so. Yeah. All right, let's get started here. Apologies again for that delay. Hopefully I can speed us up a bit and get us going. Okay, so I am a PyLadies co-founder. I am relocating to Berlin in a couple of days. So if you live in Berlin or know somebody who I should meet, please come say hi. So why scrape the web? This is becoming more and more of a question. There's a lot of public APIs. There's lots of REST or JSON-enabled endpoints, both public and not so public, but easily found upon investigating websites. There's also a lot of well-maintained open source API libraries. So those, again, allow us to scrape Twitter, Facebook, whatever it is we're attempting to use without really using the traditional scraping libraries. For Python, Selenium is still your best bet if you need anything that does JavaScript interaction or that's loaded after the DOM. So you're kind of a little bit shackled there. There's plenty of node libraries out there, but in Python, that's really all you have. And albeit with all those caveats, I still think that there's a lot of sites where you can build a traditional scraper and scrape content that way, and I still find it very fun to build those for my own use. So what this talk is going to cover, I'm going to look at different performance within LXML and BeautifulSoup. I'll go into a little bit more why I narrowed it down. I'm going to talk about finding elements with Selenium. So a lot of us who've used Selenium, there's many options for finding elements. I'm going to talk about which is the fastest. And I'm going to take a look at Scrapy or Scrapy, I'm not quite sure the pronunciation, and see how fast we can go with Python and scraping the web. So a bit of a disclaimer, when I first was putting together the test for this, I wanted to use quite a lot of scraping libraries. What I found as I began to look at it is a lot of them were using similar dependencies, and so I decided that it might be of best use to hone in on some of the most popular ones and most widely used ones, which is what led me to LXML and BeautifulSoup. I also, in this, I kind of wanted to find some broken pages. I've been scraping using LXML for some years now, and it often would happen to me where I'd come across a page where BeautifulSoup was truly my only option to accurately parse the page. I think HTML5 is changing this landscape and hopefully allowing us to have more standardized web content, which allows us to scrape the web utilizing the element tree APIs and other things similar to that. If you find, of course, broken pages, BeautifulSoup and HTML5lib also have quite a lot of helpers for scraping, truly broken pages that don't follow any sort of uniformity of tags. And all of my code for this talk is available at my GitHub. So I created a repository, I believe, called Web Scraping Speed Comparison. And you can please fork it, download it, play around with it, prove me wrong with my own tests. So I wanted to compare LXML and BeautifulSoup. A lot of times these are, the commonly and most popular used. They use distinctly different methods to unpack and parse HTML, so I wanted to kind of take a look at those methods. And both of them I find to be tremendously accurate with the right level of detail. So I feel like a lot of it is up to the developer. The onus is on you to kind of write your scraper in such a way that you're accurately finding the data. But I find them fairly easy to manipulate for this purpose. And LXML utilizes both XPath and CSS select, so I decided to compare those. Me, myself, being a developer, being lazy, a lot of times I'll just rely on CSS select rather than write out the entire XPath, and I wanted to see whether I was losing a lot of time. Okay, so what was my methodology? First, I wrote accurate scrapers as best I could, and then I tried to find similar ways to parse it. So with a lot of my functions, I tried to follow a similar method of find and search so that I could continue to compare the libraries rather than my own code. I'm fairly certain I could have written these parsers to be faster by employing different fast methods of the library, but I found that maybe this might be the most accurate way. Then I used cprofile and pstats to kind of analyze how much it took for each function to run. And then I did it over a number of trials, ranging from 10 to 500. So the first thing that I decided to do is I wanted to scrape the NHL scores. I'm an avid hockey fan, and we're about to enter playoffs, and we're in Canada, so I figured I might be amongst hockey fanatics. And so I went to their scores page, and I personally am a big Gwins fan, so I wanted to see how my Gwins were going to do in the playoffs. This is the only code I'll show you, and apologies again for trying to fit it all on one slide. Again, the repo is up on my GitHub at kjam. But basically, you can see here I have my LXML with XPath, LXML with CSS, and BeautifulSoup. And I attempted to employ similar ways of unpacking and unwrapping the content, finding the scores body, then finding those game boxes, and then going within the columns to find both the team names and the scores. And here's were my results. So as you can see, LXML with XPath was a clear winner here. It was way under even 0.06 per run, as well as BeautifulSoup took the longest. It was up to nearly 0.24 seconds per run. You can see that LXML with CSS was just a close second, particularly as the averages got higher. And we could take a little bit of a look here at why and where this speed might come from. So we see LXML with XPath has 238 function calls, far below the 280,000 that BeautifulSoup averaged. So we can start to see maybe this is where some of the speed of XPath is coming into play. Again, these varied by run, but I didn't see a large disparity amongst runs. And so then in an accuracy review, all of the different scrapers were able to accurately find all of the game scores. And just so that you can run these as well, in the repository, I also included the source of the initial pages I was scraping. So the next thing I decided to do is I have a bit of an e-commerce background as well, and e-commerce sites are notoriously messy. And so I decided to scrape Amazon deals. So I can get my deal of the day in my email, but what about these lightning deals across the bottom? What I wanted to do is grab the title, the link, and the price. And what I found in running it is, again, LXML with XPath was the winner. But we see here that depending on the site content and how quickly it can be parsed, BeautifulSoup was only several hundredths of a second slower. So we can start to see, hey, you know what? All of these are pretty fast options. Yes, LXML with XPath is the fastest, but we can start to see that depending on the page, we're going to have a variety of times. But again, when I looked at the function calls, I saw just far less overhead with XPath, even then with LXML using CSS select. So in an accuracy review of this, oddly enough, BeautifulSoup was not able to properly parse using the same sort of syntax as the others. And I actually was having a hard time even getting to that part of the page without using a whole family tree crawl. And so what I determined, or what I did is I modified it so it would find the top deals, so it could be at least comparative. I wasn't going to sit there and compare, 20 to 30 lines of BeautifulSoup with 5 lines of LXML. But this was actually an interesting find for me, so I thought I'd share it. The third and last case study that I did in terms of scraping was I looked at New York Times mobile site. I definitely wanted to do a mobile site because mobile sites, as we all know, are generally more lightweight, they load faster, they usually have less JavaScript and other junk running on the page. And what I did was I grabbed the headline, the link, and the blurb, if it was available, of the New York Times mobile homepage. And again, I found that we had tremendous speed with all libraries. If you can't see from across the back, even BeautifulSoup is clocking in at 4.5 hundredths of a second. But LXML with XPath was just super, super speedy. And what I found here, again, with the average function calls, XPath was a little bit more than I had expected given the other runs. But regardless, it still was much fewer calls than the others. And again, in accuracy, they all found 17 articles, and there was a null set at the bottom. I'm assuming New York Times uses it for some sort of style divider. So LXML with XPath is the clear winner here in terms of speed. But at the end of the day, it's really not by much. So I would, again, I would caution against saying something like BeautifulSoup is slow. That's just not true. And I would caution against saying LXML with XPath is the fastest thing in the world. But it is pretty fast. And if you're looking at scraping quite a lot of data, it would definitely be worth investigating, right? So I'm going to take a look at Selenium. Selenium, by far, if you're using Python, is the best for page interactions or after DOM load elements, especially anything that has like login flows and things like that. I find it's just really useful. Selenium also gives you a whole lot of ways to find elements on the page. And I wonder to myself, when I code Selenium things, I mean, I'm already losing so much time loading a browser and clicking through things. What's going to be the fastest in terms of finding elements? And so I'm going to compare find element by tag name, find element by class name, and find element by XPath. There were others to compare, but I find that I use these the most. So I decided to go to yahoo.com, and I wanted to find the search box, and I wanted to find this little trending now section. It's trending across Yahoo, I guess, so I was curious as to what was there. What I thought is maybe this might be a good start script for going about and searching different search sites and seeing what they came up with, how many results were similar or different. This just will compare the find, though. And what I found is that, again, we're dealing with really hundredths of a second difference. I found that with the shorter runs, CSS sometimes beat XPath. This was one of the times that it did, so I wanted to show that. And, but still, we see that XPath, over the average of many runs, clocks in as the fastest, and tag name actually ended up being the slowest, which was surprising to me. I assumed kind of that tag name used XPath underneath the covers, but that might not be the case. If somebody works on Selenium or understands Selenium better than I, maybe you can best explain this. But when I looked at the function calls, I found that XPath had quite a lot more than I expected. This probably has to do with the fact that Selenium is most likely using a rendering engine more similar to the browser, whereas Find with CSS had a very low number of function calls in comparison. That made me think that if you're running quite a lot of Selenium, maybe CSS is going to be the best way. Tag name here was the clear loser. CSS and XPath are both great. Tag is clearly slower and with more calls. But similarly to my find with web scraping libraries, it wasn't that huge of a difference. And again, you want to think about what you're comfortable with, what your team is comfortable with, and what is readable to you, and use what makes the most sense for your script. So I wanted to investigate Scrapy. It uses LXML XPath to find elements, or as they call them within the library, items. And it uses twisted for asynchronous crawling. So to me, it seemed that it was going to be really speedy. Also, Scrapy, I've seen it evolve a lot over the past 2 years. I've kind of been following it, watching it grow, and it's just become quite powerful in terms of crawling and spidering the web. If you haven't used it yet, I cannot encourage you enough to go about building your own crawler. They just have a lot of really robust functionality and helpers for you. And so with our speed knowledge, I was wondering, how fast can we go? So what I wanted to do is I was going to query Google with pagination for search results. Within those search results, I would find the title, the blurb, and the link. I didn't worry about saving it to disk, or I didn't want any writes messing up my speed tests. So again, that's going to add some time depending on your script. So I Googled Python because I thought, why not? And so here's a bit of my stats. You can see my C profile stats at the bottom, but I was having to use a command line caller from within the Scrapy library to get it running. So, but you can see the item scraped count is 306. If you look at the start time compared to the end time, we're talking about slightly, like a shave over 3 seconds to get 306 results. So, scraping Google, the spider was averaging almost 100 results a second, or around about, sometimes a little over, sometimes a little under. To me, that seemed tremendously fast, and it was really exciting to see how powerful it could be. Also, Google hates me. So I caution you against running this script at home during off hours. I was captured to death. But I found that if you run it during the busy times of the day, in the morning hours, whatever your time zone is, maybe Google will hate you less. A lot of times I could get through up to 340 results, and about the 360 mark, or whichever one with twisted finished the last I would get captured. And also, Scrapy has a bunch of different tools, very similar to what we saw in the mechanized functionality, for those of you that are familiar with the mechanized library, to get around CAPTCHA blocks. You can use different user agent strings, you can use different IPs, and other things like that. So for this test, I wanted to, rather than see how quickly I could fool Google, I wanted to see how quickly I could get the scraper running. So, but it's easily forkable, or to write your own and use some of their logic to scrape Google even faster and at more length during off hours. So, in conclusion, LXML using XPath is the clear winner when it comes to speed. For readability and accuracy, though, both in the code and the content that you scrape, you know, it's really, the time difference was not as amazing as I thought. It was amazing enough that if you're parsing thousands of websites, it's probably going to make a difference to you. But if you're just writing a scraper at home for your favorite restaurant, or finding local deals near you, or whatever it might be, then I don't think there's a big difference, and it's going to end up being, you know, what is easiest for you to install, what's easiest for your team to use, and your code, again, might vary. So there are ways to speed up BeautifulSoup depending on the way that the page is parsed. And I would advise using those if you are set with like a Windows operating system or something else where LXML becomes a big pain in the rear to install. And then if XPath is too confusing or limiting, if you're really into web scraping, I strongly encourage you to learn XPath. It's really fun and super powerful. But if it, for some reason, is too confusing or limiting, or you're feeling lazy, CSS Select is obviously a close second choice. So I would say to use that. So I'd like to invite you to ask questions. Again, thanks for staying with me. Apologies for my technical difficulties. I am KJam on Twitter if you'd like to hit me up later if you want to explore the repository first. I also idle on Freenode as KJam. And thank you so much for coming to my talk. And if you have questions, there's a microphone right there.
Hi.
Hi.
I guess this is kind of a comment and then a question.
Okay.
But I happen to use Selenium quite a bit at my job.
Oh, excellent.
So I think that utilizing function calls as a way to determine what the performance of Selenium looks like isn't actually a fair representation.
Oh, okay.
Mainly because Selenium is actually a protocol that communicates with browser, and it's kind of language agnostic. All the Python interface is doing is just calling a remote interface that communicates with it. Mm-hmm. So you probably wouldn't figure out why the performance is lacking or very performant that way.
Okay.
And also the various calls that WebDriver actually incorporates. WebDriver is the underlying interface for Selenium. Sorry, I know this is kind of in-depth, but it actually depends on how the browser chooses to implement that protocol.
Okay.
Some choose to use the existing JavaScript engine. Others utilize more built-in functionality.
Do you have advice on which driver is the fastest?
Yeah, it's Phantom.js is actually a headless browser that works, and you can run thousands of processes. That's what we do at my job, and it tends to be a lot faster than, I'm guessing. I mean, most people tend to use Internet Explorer or Firefox, and yeah, we found. 10 times, depending on what kind of test you're running.
There's also a headless Chrome now as well, yes?
A headless what?
A headless Chrome browser driver that you can use.
Nice.
I was wondering just if you knew the comparison between the headless Chrome and the Phantom.js.
I haven't tried the headless Chrome.
Cool.
And I was curious what browser you chose to use for your Selenium tests.
For the Selenium test, I just used Firefox. So yeah, it's fairly slow. Usually I use Chrome, but I wanted an example that was easily portable for everyone.
Gotcha. All right, thank you.
Thank you.
Hey, thanks for the talk. Just curious, what was the most interesting and or useful and or cool, I guess, thing you scraped?
In all of my time scraping?
Yeah.
Probably at one point in time, I was using a service with my company. We were utilizing a service to help us with some logging, and I exposed basically a hidden API. At some point in time, I just pinged the dev team and said, hey, I found that I can go back like a year, but if I wanted to go back more than a year, what could I use? And they wrote me back saying, we're closing that API endpoint, so apologies. I didn't mean to be evil. Any other questions? All right, thank you so much, and have a happy PyCon.